You are about to see something that seems impossible. James Webb pointed toward one of the oldest regions of the cosmos and found something that shouldn't appear so early. A silence, an emptiness, a stretch of the primordial universe where, in theory, there should be signs of galaxies being born, but there's almost nothing. And do you know what makes this even more unsettling? More than 100 years ago, Albert Einstein and relativity were already suggesting that there might be a real physical limit, a point where the universe simply stops answering us, an invisible horizon that no telescope can cross. Today you're going to understand what physics predicts about the limits of observation, why there is a wall in the cosmos, what exactly James Webb found, and why some scientists became uncomfortable with it. And at the end, the terrifying question, is this just an empty region, or are we looking at the limit of the very beginning? 100 years ago, scientists thought the universe was basically the Milky Way. Everything else looked like a black canvas with a few bright dots. But then observations improved, and they realized something that changed everything. Those nebulae weren't clouds inside our galaxy, they were other galaxies. And when Edwin Hubble discovered that those galaxies were moving away from us, the world understood a massive idea. The universe is expanding, and if it's expanding now, then in the past it was smaller. If you go back in time, you reach an inevitable conclusion. There was a moment when everything was concentrated in an extremely dense and hot state, the Big Bang. Einstein accepted this possibility as a mathematical consequence, but he was certain of one thing. Even if the universe had a beginning, we might never be able to see it directly. And this wasn't a hunch, it had a foundation in physics. And he said that for two reasons. The first reason is what cosmologists call the cosmic dark ages. In the first hundreds of millions of years, there were no stars like ours, no mature galaxies, and most importantly, there was no visible light traveling freely through space. It was a universe filled with gas, dark matter, and small fluctuations, but practically no cosmic lighthouses. So how could we observe anything with telescopes if there weren't any stars shining? The second reason is even more disturbing. Relativity and cosmology show that there is a real limit to how much we can see. A kind of wall, not made of matter, but made of time, expansion, and the speed of light. The universe is so vast and expands in such a strange way that there are regions whose light will never reach us. No matter how long you wait, no matter how powerful the telescope is, there's a limit called the observable horizon. Like the horizon on Earth, you can run toward it, but you never reach it. And this is where James Webb comes in. James Webb was built with an almost impossible goal: to capture the oldest and faintest light in the cosmos, light that has traveled for more than 13 billion years. It observes mainly in infrared, which allows it to see galaxies whose light has been stretched by the expansion of space. It's like a time machine. And when it began looking into the past, it found something that surprised everyone. Very ancient galaxies, brighter and more massive than expected so early on. It seemed like we were getting too close to the beginning. But then, in some of these deep observations, a pattern appeared, and the conversation changed tone. A region with an abnormal deficit of galaxies, a huge patch of sky where, statistically, there should be more signals, more smudges, more structures. And yet Webb recorded far less than models predicted, as if the primordial universe had a glitch, a hole in its distribution. Now understand this. Voids do exist in the present-day universe. We know cosmic supervoids, regions with fewer galaxies. But in the extremely young universe, that's much harder to explain because according to standard cosmology, the early universe should have been more uniform, more homogeneous. Small irregularities, yes, but a region that's too silent, too early. That raises a red flag. And then the question emerges, the one nobody likes to say out loud. Is this void real? Or is it a limit of what we're able to observe? Here's what makes this terrifying. If this region is just a statistical variation, an area where matter was less concentrated, then it's simply a strange but possible cosmological anomaly. But what if it isn't? What if it's a sign that we're approaching an era where light didn't yet exist in the way we understand it, or where light doesn't travel freely, or where space-time itself, the way we describe it, didn't even make sense yet? In other words, no matter how powerful our telescope is, we will never see the beginning. And that would confirm a chilling consequence of relativity and cosmology. The universe may have an invisible boundary of observation, not a physical edge, but an absolute limit of information. Today, there are three major hypotheses scientists discuss when voids or deficit regions appear in deep observations. The first hypothesis is the simplest. Maybe Webb is capturing an era very close to what's called the Dark Ages, meaning it looked at a period where there still weren't enough stars to illuminate that stretch of the cosmos. It wouldn't be nothing. It would be the universe before it turned on. The second hypothesis is stranger. Maybe there is matter there, but a kind of matter that doesn't emit light, or a dark matter structure influencing the gas, preventing stars from forming efficiently, like a gravity that exists but doesn't shine. And the third hypothesis is the most disturbing. What if this is a real limit? Not a void of matter, but a limit of observation, as if we're looking at a point where the universe itself had not yet become transparent to light, as if we're trying to see something that, by definition, cannot be seen. And that leads us to an even bigger question. If the universe began in an extremely dense state, what existed before? Science answers with a terrifying concept: singularity, a point where the universe's energy was condensed, where time doesn't behave the way we know it, and where the laws of physics stop working. And here comes an unsettling detail. We believe singularities exist inside black holes, and almost every galaxy has a supermassive black hole at its center. So some scientists and theorists raise a hypothesis that sounds like science fiction. What if the universe began as a kind of event similar to a black hole, but reversed, as if the Big Bang were an inverted horizon? And if this silent region in the observations, this void, isn't a hole in the universe, but a scar, a mark of the moment space-time was born? We still don't know. But one truth is clear. James Webb is pushing science to the edge, and maybe that edge is exactly what physics predicted. The most powerful telescope ever created looked into the past and found silence, a region with less light than it should have, fewer signals than the model expects. A place where, for an instant, it feels like reality refuses to reveal what came before. And maybe that's the most frightening part of all. It's not that the beginning of the universe is hidden. Maybe it's beyond a horizon no instrument can cross, as if the universe placed a lock on its own birth, and we're outside, trying to listen. And all we hear is an echo. If you want more videos about the most disturbing discoveries of the cosmos, subscribe now, because the next one will make you question what you think reality is.